Right, we all love a good sequence question. So, like, find an expression for in terms of n for the nth term of the sequence. Now, it's really easy to find this super difficult, but my brain is going, right, what would the next, if I looked at the question on this, what would the next number be? So I'm trying to find out how I go from 3 to 11, and from 11 to 19, and 19 to 27. So hopefully, if you had to guess the next number, you'd be able to get the number 35. Why is it 35? Because I know that every time I go across, I'm going up by 8. So actually, knowing that it goes up by 8 is a really useful thing, because it means I can write down my 8 times table. Okay, so whatever it's going up by, that's how many n's I need. So my sequence that goes up by 8 is like 8 times table, which is called 8n. And as soon as I write that down, I get a mark. Really easy. But then I think, well, if it was my 8 times table, it would be this sequence. So how would I turn my 8 times table into this bit? Well, what do I need to do to it? I want to go from 8 to negative 5. I need to count by 8 and another 5. I need to subtract 13. And hold on, let's just look at that. If I went from 16 to 3, I'd need to subtract 13. And if I went from 24 to 11, I need to subtract 13. So actually, my sequence is just 8n subtract 13. Right, this one. Dividing by decimals. Now, I like to write a division as a fraction. Okay, I like to write division as a fraction. So I don't really like the idea of dividing by something that isn't a whole number. So I'm going to write an equivalent fraction. So I'm going to make that 84.6, so 10 times bigger. And I'm going to make that 1.5. But I'm going to go again, because I still haven't got a whole number as my denominator. So now I'm going to change it to 846 divided by 15. All of these are equivalent fractions. So now I know that if I can answer this one, I've actually answered all of them. But I don't know about you, I'm not great at my 15 times table, so I know I'm going to need to use that a few times. So I'm just going to write down my 15 times table. And it might take me a bit longer to write it down, but it means I don't have to check it every time. So here we go, 120, 135, and I'm going to stop at 10, because I know, in theory, when I'm doing my division method, I should never have to go past 10. Right, so how many 15s make 8 or 0? But I haven't used any of those 8, so now I'm going to go up to 84. One, I can make that, can make that, can make that, can make that, can make that. I can't make this one. So I can make 5, and that gets me to 75. But then I've got to get up to 80. I've got to get up to 84, so I need another 9. So now how many 5s get me up to 96? Well, how many 15s? So 1, 2, 3, 4, 5. So I can make 6, and that gets me up to 90. But I've still got 6 left over, so I'm going to need to go into my decimals. So I've still got my remainder of 6. So now I've got the question, how many 15s make 60? 1, 2, 3, 4. So I've got 56.4, and that would be my answer to this question. But for 3 marks, that is something we can certainly practice and get better at. This one, right, write this as a mixed number. So again, we've got 3 marks on this question, so it is worth trying to make sure that on a non-calculator paper, it's a skill that we can practice. So I'm going to change this into a top-heavy fraction. So imagine I've got 8s. So this first bit, I've got 8s. And to make a whole shape, I need 8 of them. But I've got 7 whole shapes. So I've actually got 8 eighths 7 times, which gives me 56 eighths. And I've also got 3 more 8s, so that takes me up to 59 eighths. So that would be my top heavy fraction, the equivalent of that. This one I've got halves, so to make a whole I would need 2 halves, and I've got 2 wholes, so I've got 2 halves times by 2, so it gives me 4 halves, plus another half, so that gives me 5 halves. So now I've got them as top heavy fractions. Now, when I'm trying to do an addition or a subtraction, I always want of fractions, I always want my denominators to be the same. Now, if I went up in my 2 times table, and I went up in my 8 times table, what number could I get to? Well, I could get to 16 or 24 or 32, but probably the easiest one to get to is just the number 8, because I've already there once. So I'm just going to take this fraction and I'm going to think, how do I modify this fraction to turn it into 8s? Well, I'm going to need to multiply the bottom number by 4, the denominator, so I need to multiply that numerator by 4 as well. So that's going to give me an answer of 20 over 8. So if I do a subtraction, that gives me 39 over 8, which is 4 wholes and 7 eighths. Let's just talk about why that is. So if I've got 39 dots, and I'm trying to put them into groups, I'm going to go up in my 8 times table. So that would be 1 in each group, 2 in each group, 3 in each group, 4 in each group. So that I can make 32, but my remainder from 32 up to 39 would be 7. So that would give me 4 and 7 eighths as a mixed number. Right, this one. So this is actually the first question on the higher paper as well. For those people who are on the looking for those higher grades, these are the ones you need to get right. A cube has a total surface area of 150 centimetres squared. Now, think about that cube. How many faces has that got? How many faces has that got? I think it's got 6 faces, like a dice. Yeah? So altogether, those 6 faces give me an area of 150 centimetres squared. So if I just had one face, I'm going to have to take those 6 faces and split it 6 ways, because they're all squares, they're all the same size. So I'm going to divide that by 6, and that gives me a 25 centimetres squared. So now I know that each one of these is 25 centimetres squared. So now I know that, what have I got? I know that each length is 5 by 5, because 5 times 5 is 25. So I know that each of my lengths of my cube is 5 centimetres, are 5 centimetres. Sorry. So then I need to work out my volume, which is going to be 5 centimetres times 5 centimetres times 5 centimetres, and that's going to give me 125 centimetres squared. Done.